Hello, and welcome to Summarize Science. Today, the topic is about a fascinating problem in computer vision: how to make robots see transparent objects clearly. It turns out, standard depth sensors struggle with things like glass and clear plastics. These sensors rely on how light reflects off surfaces, and transparent materials mess that up. The PDF introduces a novel self-supervised learning method to address this challenge. The main problem the research addresses is that training robots to see transparent objects usually requires a lot of labeled data, that is, images where the depth of transparent objects is carefully marked. That's expensive and time-consuming. So, the researchers came up with a clever trick. Instead of relying on labeled data, their method lets the robot learn by itself, by simulating the depth perception issues that transparent objects cause. They do this by artificially masking portions of non-transparent objects in images. This simulates the incomplete depth information that a robot would get when looking at something transparent. The robot then learns to fill in these gaps, using the original, complete image as a guide. This way, the robot can train itself without needing any labeled data. Figure 1 on page 1 shows the idea. The original RGBD sensor has difficulty capturing the depth of the transparent object. The new method simulates that effect by masking the depth of non-transparent objects. The researchers used a technique called SAM to identify regions of transparent and non-transparent objects. They then eroded the masks to mimic the way depth sensors can still see edges of transparent objects. These steps create artificial deficiencies for training. Check out Figure 2 on page 3. It visualizes how supervised learning requires the full depth information, but the new self-supervised method uses the masked data. Figure 3 shows the overall masking strategy, where the SAM model plays a crucial role. They tested their method on a well-known dataset called TransCG. Table 1 on page 4 shows how their approach compares to other methods. The Rs row shows the quantitative performance. It's very close to fully supervised learning and clearly outperforms MAE. Table 2 explores fine-tuning with limited training data, and the new self-supervised method does a good job pre-training. Figures 4 and 5 show the visual improvements. The error maps show that the new method significantly reduces depth errors, more so than alternative methods. The erosion strategy helps model the target transparent object depth accurately. This research is significant because it provides a more efficient way to train robots to perceive transparent objects. By removing the need for extensive labeled data, it lowers the cost and complexity of developing robot vision systems. That means we could see more robots working in environments with transparent objects, such as warehouses, factories, and even our homes. For example, robots could more easily sort recycling, handle glassware in kitchens, or perform intricate tasks in manufacturing. To recap, this research introduces a self-supervised learning approach for transparent object depth completion. It simulates depth loss by masking non-transparent regions, trains the robot to fill in those gaps, achieves performance close to supervised methods, and offers improvements in fine-tuning with limited training data. All of this translates to cheaper and easier to implement robot vision systems that can handle transparent objects. Thanks for watching, and see you next time on Summarize Science.